Welcome to this lecture on creating views. This is a fun and fairly easy task for us to tackle because the magical thing about views is they're really nothing more than the defining select query. And then when we get the select query built, we just package it up as a view. So let's take a look at some exercises that are similar to the exercises that were assigned in your assignment activity, your exercises. And so we're going to work with the My Guitar Shop database for this exercise. The first problem statement says, create a view named customer address that shows the shipping and billing address for each customer in the My Guitar Shop database. This view should return these columns from the customers table, customer ID, email address, last name, and first name. This view should return these columns from the addresses table: bill line 1, bill line 2, bill city, bill state, bill zip, ship line 1, ship line 2, ship city, ship state, and ship zip. And let's see. Oh, use the billing address ID and shipping address ID columns in the customers table to determine which addresses are billing addresses and which are shipping addresses. And there's a hint here that says you can use two join clauses to join the addresses table to the customers table twice, once for each address. Okay, so it's kind of similar to what we do when we do a self join. We'll just declare the same table in there and give it a different alias, and then we can treat it as if it's a separate table. So that's the only twist on this one. Let's get started. I guess let's comment out here a creation statement to turn this into a view. That's the only thing that we're going to need to turn it into the view, is to preface it with create view and then give it the view name and the as clause, and then everything that follows is just a normal select query. So the heart of the matter is to build the select query. Let's start with select star from, and the tables that are going to be involved here are going to be the customers, the addresses, and that's really it. But here's the twist. We want to reference that addresses table from two perspectives, one to get the billing address and the other to get the shipping address, even though both of them are in the same table. So let's reference addresses again. And let's come in, and to make this a little less confusing, let's put aliases in for all the tables. So let's call C customers, and that first addresses table that's going to be the billing address, let's call that BA for billing address. And that second instance of it, let's call it SA for shipping address. Okay, and let's see. If we've got 3 tables, we're going to need to see 2 equal signs if we use an implicit join. That's usually my preference for equijoins. You could also use the join clause explicitly and come up with exactly equivalent logic, so that would be fine. So let's add a where clause, and we want C dot something equals BA dot something, and we want also to have C dot something equals SA dot something. What are those somethings? So let's think about this. We want the billing address from the customer, and we want the billing address here. And then the shipping address and the shipping address here. Only that's going to be address ID, right? same thing on this side. Address ID. Okay. And let's see where the problem lies. Incorrect syntax near the equal sign. Well, let's comment that out for a second, see what the problem is. If I do that, is that fine? That's fine. Only that's all right. Okay, so let's see where our problem is here. C.billing address equals oh, I got an extra period hanging. There's the problem. Okay, it's always the little things. All right, and there we go. So we got this big mess. We need to start trimming it down to only get the pieces that we want. Okay, so let's see here. We want the customer ID from the customers table. And we want the email address. And there's only one of those, so we don't have to disambiguate or fully qualify it. And the last name only shows up there once, so that won't be ambiguous. And same thing with the first name. All right. And then there's some more stuff. Let's see. From the BA, we'd like to have line 1. And we're going to alias that. Let's call it as bill line 1 and BA line 2. And let's alias that as bill line 2. And then we want the city. And let's call that as bill city and the state, and we'll call that bill state. And billing address zip code, and we'll call that bill zip. And then let's see, from the shipping address table, we want line 1, and we're going to call that ship line 1. And line 2, call that ship line 2. And then the city stuff, sa.city as ship city, sa.state as ship state, and the zip code as ship zip. All right, I think we have it. And that's looking pretty good. And so let's go ahead, and if we're happy with the select query, we can wake up the lines we commented out and create the customer address view. And look like that's completed. successfully. And so let's go ahead and just exercise it right quick to test it. Select star from customer addresses. Let's just run that piece. And there it is. So that view is in place and that is working correctly. And so now our next task, that's our exercise 1. Exercise 2 then becomes really simple because we're going to use that view, and it says, write a select statement that returns these columns from the customer addresses view that we just created. And we're going to return the customer ID, the last name, the first name, and bill line 1. Okay, well, we could start with select star from customer addresses. Exercise it, that's working, okay. So now that we've got that, we wanted only the customer ID and the last name and the first name and the bill line 1. And there it is. Okay, customer ID, last name, first name, bill line 1, same number of rows we were getting before, and we are good to go. That's exercise 2. Just really simple stuff. We've done all this before. The only difference is adding the preface to create view as to actually create the views. Okay, so now this view, let's think about this view that we created. It has the primary key in it. So of all the tables, so we can do some updating on it. And the next exercise wants us to do that. So let's take a look at what that exercise says. I'm just going to paste the text of the exercise right here so we can look at it. So we're going to write an update statement that updates the customer address view that we just created, so that sets the first line of the shipping address to 1990 Westwood Boulevard for customer who has an ID of 8. And we see down here from the last query, there is a customer with an ID of 8. So let's see how would we go about doing that. Okay. So it's going to be an update statement, and we're going to update customer address. And we're going to set bill line 1 to the value of 1990 Westwood Boulevard, but only where the customer ID is 8. So only for Heather Esway. Okay. And of course, there could be 2 people that have that exact same name. So this is the safer thing to do if we're doing it in business. A lot of times in our exercises academically, I will give you just the first name so that you get the understanding that you don't necessarily have special knowledge of the customer ID. We could always look the customer ID up, and what's nice about this is that's not ambiguous. So if there's John Smith from Van Nuys and John Smith from Culver City, we're making sure we get the right John Smith, in this case, the right Heather Esway, who's customer ID 8. Okay, so let's, before we fire that off, let's do this right quick. Select star from customer addresses. And let's copy that clause in there. And let's see. Also, I see there's too much red here, and that means I've blown closing a quote. I used a double quote instead of a single quote. Okay, so let's just see this before we actually pull the trigger on the update. And there's Heather Esway, and currently the bill line 1 says 291 West Hollywood Boulevard. We're going to update that to 1990 Westwood Boulevard. And so let's run that. It says 1 row affected. That's what we'd expect. And now let's sanity check our work. Oh yeah, now Heather Esway is here on 1990 Westwood Boulevard. So that view is updatable. That worked just fine. Okay, now let's move on to exercise 4. And exercise 4 says create a view named order item product. So we're creating a new view that returns columns from the orders, order items, and product tables. Okay, so we've got 3 tables we're going to have to join together. And the view should return these columns from the orders table: order ID, order date, tax amount, and ship date. And the view should return these columns from the order items table: item price, discount amount, and final price. And final price is going to be a calculated field, and we're going to calculate it as the discount amount subtracted from the item price. Then we also need to list the quantity and item total. And the item total is going to be the calculated total for the item. So we have a couple calculated fields in there that we're going to have to wrap our head around. So we'll start again with selecting everything and then playing with it till we whittle it down and bang it into shape. So we're going to create this view, and that's what it's going to be called. And again, I'm going to start off putting that to sleep. And let's focus on getting the select clause in there correctly first. So let's start with select everything from, and let's get it from the orders table and the order items table and the products table. And let's save a little typing by aliasing these. Call that P, call this OI, or for line items, we'll make it LI. And for orders, just O. Okay. And if I've got 3 tables, I ought to see in an implicit join, I ought to see 2 equal signs in the where clause. And where, and we're going to have O dot something equals LI dot something. And we're going to have LI dot something equals P dot something. Okay, so the O dot something is the order ID, is the key. And LI order ID. And then the line items are going to be joined on product ID with products dot product ID. Okay, that's looking pretty good. Let's just exercise that. Okay, that much runs correctly. And 47 rows, so it seems like I've got the joins tied up, no Cartesian products happening there. And now let's thin this down a little bit to just the fields that we want. And so some of those fields are pretty straightforward. Let's enumerate the straightforward ones. There's a bunch of the fields we want. And then we also want the quantity, and we're going to have 2 calculated fields. So let's try this much. Order ID, order date, tax amount, ship date, product name, item price, discount amount and quantity. That's all looking really, really good. Now let's think about what we need to do on the final price. Okay, so let's make a couple notes here. We want final price, and we want item total. So final price is equal to what? And let's make it clear, these are comments, not code. So I'm just thinking through my problem. So the final price, it says in the exercise, is determined by taking the item price and subtracting the discount amount. And then we just alias it as final price. So let's take that expression. And where would we like that? How about following the discount amount? So let's come up here and put that in, comma, and so far so good. Does that work? Sanity check it, discount amount. Okay, that's looking good. And so that takes care of final price. Now, how do we calculate this item total? The item total is going to equal, well, it's the quantity times something. How many line items, how many of that line item did I buy? Quantity times, and yeah, okay, so it's going to be the expression item price minus discount amount, right? And that is going to be the item total. Great. So let's take this part of the expression we just built out. And where would we like that to be? Let's just make that the last field. Comma, there you go. Get rid of our notes here and give that a shot. And sanity check that. There's our item price and the discount amount. And so it's about $350 from about $1,200. So if it was 400 less from 1,200, it'd be about 800 and something. It is 800 and something. There's one of them, and that makes sense. Let's find one where there's more than one. So 2. This is final price was $839. Should be 16 something. Yeah. Okay. So quick sanity check makes sure that's looking good. And with that looking good, we can take and wake up the create view statement and run it. Should get completed successfully. Good. And now let's just exercise that. Select star from order item products and run that. And that should just give us, yeah, the same as if we'd selected just the select portion of that create view. So now we've got that view running. So that solves exercise 4. Well, what do you want to bet that exercise 5 does something with that view? No, it doesn't though. All right, so exercise 5 says create a view named product summary. So let's go ahead and clean this up, get it out of our way. And here's our problem statement for exercise 5. Okay, so we're going to create a view named product summary. So let's go ahead and park that. Create view product summary as, okay, and for now we'll just put it to sleep. That uses the view. We're making a view that uses a view. Can you do a view on a view? Sure, like a query on a query. Interesting. Okay. And it's going to use the view we created in exercise 4, which of course was the order items products. Okay. This view should return some summary information about each product. Okay. Each row should include these columns: product name, order count, and order total. So I got a couple of calculated fields. Let's run this part. So there's everything. Now we want to trim it down so it just gets these things: order count, which we don't know what that is yet, and order total, and we don't know what that is yet. They're going to be calculated. So we're really just looking at 3, and we've got a couple aggregate functions in there. Okay, because we're going to be looking at a count, and we're going to looking at a sum, and right away that tells me that I'm probably going to have a grouping if I'm going to do aggregation. And let's see, we're going to get the product name and then the 2 calculated. So the only thing I can group by is product name. Don't even have to think about that. They didn't ask for any ordering, so I guess we won't worry about the order. And let's see here. Order count is going to be the number of times the product has been ordered. So that is going to be the count of, well, let's count the product name, right? Every product has to have a product name. And we'll alias that as order count. And then we've got another calculated field here. Let's take that and just put it aside for a moment and see about that. Does that work? Yep, there's my counts. Nice. Okay. And so now let's wake this up and fix it. And we want order total is going to be, so we're going to call it order total. Let's go ahead and just move the alias out to the end where it belongs. And it's the total sales for the product. So the total is calculated by finding a sum, and it's going to be the sum of the item total, right? Does that work? Let's give it a shot. Run that. Cool. And sanity check it. 5 of those, totaling that seems kind of reasonable. And 3 of those, totaling that seems like it's reasonable. Fewer of them tends to have lower numbers, more of them has higher numbers. So that feels good. So just a basic sanity check. And then now that we've got that, let's go ahead and create the view. So let's wake this up, uncomment it, and run it. And it says it completed successfully. Let's prove it. Select star from product summary. Highlight just that and run it. There it is. Neat. Okay. That's working pretty well. Wow, we've only got one exercise left. Okay. So let's put this aside. A view on a view. That was fun. Let's take a look at exercise 6. I'm going to paste the instructions in here. Write a select statement that uses the view that you created in exercise 5 to get total sales for the 5 best-selling products. Okay, so looking back at exercise 5, that was the product summary. I don't know why they have to word it that way and not instead of spelling it right. The view. Yeah, product summary that you created in exercise 5 to get a total sales for the 5 best. Oh, and we're going to use it to get the total sales for the 5 best-selling. Well, that's a top-in issue, isn't it? Okay, so let's start with this. Select star from product summary, order by 5 best-selling products. So that's best-selling by, do we mean by the quantity or total dollars? I guess we're going to do that by order total. Okay. I have a little bit of a bone to pick with the author's design on that, because best-selling means what you sell the most of, and it looks like what the author means is best-selling by gross sales dollars. So okay, it's always the devil's always in the details with specifications. That's why it's so tough to write good specifications. Little things that give you different answers because it can be interpreted different ways. Okay, but we're looking for the order total is what we're going to figure is best selling. Okay, so let's order by order total just to get a feel for this. Okay, now the best selling is down at the bottom. So what I really want to do is make this descending. Cool. Okay, now I only want the top 5 slots. So for that, I need a top-in clause. Okay. So if other versions of the SQL language, we would use the limit clause. We're working with Transact SQL, the dialect for SQL Server. And so it actually implements top-in syntax. So we want to select the top 5. And let's see here. We don't want everything. We just want the product name and order total. And do we get it? 1, 2, 3, 4, 5, and those are the biggest numbers there. And so, yeah, we've got it. It's done. It's just that easy. And that doesn't have to be saved as a view. It just needs to be built as a query. So I think we're there. Thanks for watching.